A flat tire, middle of nowhere, no jack, no tools, no problem. Because the L9 doesn't wait for you to fix it, it fixes itself. That single feature tells you everything you need to know about how far China's automotive engineering has come. Picture this. You're on a remote highway, 2 hours from the nearest town. Your rear left tire blows out. In a Range Rover, a Mercedes GLS, or a BMW X7, you're on your knees in the dirt, wrestling with a hydraulic jack that weighs as much as a small child. You're frustrated, you're filthy, you're losing daylight. In the L9, you tap a button. The car reads the situation, activates its 800-volt active air suspension, and retracts the damaged corner of the vehicle upward, pulling the blown tire completely off the ground and into the wheel well. You unbolt the wheel, swap it out, and you're moving again. No jack, no sweat, no wasted hour of your life. This is called the single-wheel lift feature, and it sounds like science fiction until you watch it happen in real time. But the suspension doesn't stop there. Off-road recovery is where things get genuinely interesting. And when a heavy SUV gets stuck in deep sand or thick mud, the traditional approach is simple. Raise the ride height and hope the tires find grip. Usually they don't, you just dig yourself deeper. The L9 takes a completely different approach. Instead of waiting for traction, the suspension attacks the terrain. It pushes down against the ground with tremendous force, then releases repeatedly, creating a controlled, bouncing motion that physically shifts the vehicle's weight, allowing the tires to claw into fresh, undisturbed material underneath. The L9 doesn't wait to be rescued, it hops its way out. Think about that engineering logic for a moment. Most suspension systems are designed to absorb the road. The L9's suspension is designed to fight back against it. That's not an incremental improvement over what Land Rover or Porsche is doing. And that's a fundamentally different philosophy of what active suspension is supposed to accomplish. And this same structural aggression extends to how the L9 handles the worst-case scenario. Not a pothole, not a mud pit, but a full-speed collision. Independent crash testers in China set up what is known as the sandwich test. They placed the L9 between two fully loaded commercial trucks, each weighing 8 tons. The rear truck accelerated to highway speed and slammed into the back of the L9, driving it forward into the stationary truck in front. This is the kind of impact that collapses cabin structures, the kind that doesn't leave survivors. The L9's ultra-high-strength steel cage didn't collapse. The A, B, and C pillars held their geometry. The doors automatically unlocked after impact, a critical detail, because door jambs deforming under crush force is one of the leading causes of post-crash fatality. The survival space inside the cabin remained completely intact. A suspension that can lift its own corner. A chassis that can survive 16 tons of compression. Two engineering achievements that, in isolation, would be remarkable for any vehicle. Together, in a single platform, they represent something the European luxury segment hasn't encountered before. Genuine structural innovation from a Chinese manufacturer that isn't just catching up. It's pulling ahead. But the most important engineering story on the L9 isn't the suspension. It isn't even the chassis. It's the powertrain, and the way it quietly dismantles the biggest argument against buying an electric vehicle. Range anxiety. 2 words that have quietly killed more EV sales than any technical specification ever could. The fear is simple and completely rational. You're on a long road trip, the battery drops below 20%, and the nearest fast charger is 40 miles away. Even with the best DC fast-charging networks in the world, that moment of uncertainty is enough to send buyers back to gasoline. Traditional plug-in hybrids tried to solve this. They bolted an electric motor onto a conventional drivetrain and called it a solution. The result was mechanical complexity, extra weight, and a driving experience that felt like 2 vehicles arguing with each other under the hood. Li Auto looked at that compromise and rejected it entirely. Under the hood of the L9 sits a 1.5-litre turbocharged 4-cylinder engine. It has cylinders. It burns gasoline. It makes noise. But here is the detail that reframes everything. That engine has zero mechanical connection to the wheels. There is no drive shaft, no transmission connecting it to the axles. Physically, it cannot move the car forward. So what is it doing there? It is a generator. Nothing more, nothing less. Its entire purpose in life is to spin at its peak thermal efficiency, the exact RPM range where it converts fuel into electricity most effectively, and feed that electricity either into the 52.3 kilowatt-hour battery pack or directly to the dual electric motors that actually drive the wheels. This is the EREV architecture, extended range electric vehicle. And the math behind it is why it works so well. For daily driving, the school run, the commute, the weekend errands, the L9 runs purely on battery power. 133 miles of silent, zero-emission electric range. Plug in at home every night, and most owners never visit a gas station for months at a time. But for the cross-country road trip, fill the 17-gallon tank. As the battery depletes, the turbocharged generator silently activates, producing electricity on the fly. The combined result: over 870 miles of total range on a single charge and a single tank. The two electric motors deliver over 440 horsepower with instant seamless torque. The driving experience never changes. No gear shifts, no engine vibration transferred to the cabin, no hesitation between power sources. You get the performance of a dual-motor EV, the range of a diesel locomotive, and the refueling convenience of any gas station on the planet. Range anxiety structurally eliminated. Mounted cleanly into the roofline above the windshield is a 128-line LiDAR sensor. Every second, it fires laser pulses outward and reconstructs the surrounding environment as a high-resolution, three-dimensional map. It is supported by 11 cameras, millimeter-wave radar, and ultrasonic sensors covering every angle of the vehicle. This hardware array feeds into dual NVIDIA Orin X processors hidden inside the dashboard, chips capable of 508 trillion operations per second combined. That processing power runs the Li AD Max autonomous driving system, handling lane keeping, traffic response, and highway navigation. But the most intelligent use of that computing power isn't the driving assistance. It's what happens to the suspension. The LiDAR is constantly scanning the road surface hundreds of feet ahead of the vehicle. When it detects a pothole, a speed bump, or a rough patch of road, the NVIDIA chips calculate the exact moment each wheel will make contact, and milliseconds before impact, command the active suspension on that specific corner to adjust its damping rate. The wheel absorbs the hit. The chassis stays level. The passengers feel nothing. This is predictive suspension. The car experiences the road so that you don't have to. It is not a comfort feature in the traditional sense. It is a real-time mechanical response system driven by AI, a fundamental reimagining of what the relationship between the road surface and the passenger experience should feel like. No European luxury SUV at any price point currently offers this combination of LiDAR-linked, AI-controlled predictive damping at this level of refinement. Step back and look at the complete picture. A suspension that lifts its own wheel for a tire change and bounces itself out of sand traps. A chassis that survived 16 tons of compression in an independent crash test. An EREV powertrain that gives you 870 miles of range while delivering pure electric driving dynamics. A supercomputer scanning the road ahead and adjusting the suspension in real time before you feel anything. And inside, three 15.7-inch OLED screens, second-row massage seats, gesture controls that read your hand movements in three-dimensional space, and a refrigerator that doubles as a baby bottle warmer. The Li Auto L9 starts at approximately $65,000 in its domestic market. A Mercedes GLS with a fraction of this technology starts at over $90,000. A Range Rover that can't lift its own wheel starts at $105,000. For decades, the definition of automotive luxury was shaped by European manufacturers who held the advantage in materials, heritage, and mechanical refinement. That advantage still exists, but the gap in software intelligence, predictive technology, and passenger-centric engineering has not just closed. In several areas, it has reversed. The L9 is not a warning shot. It's a completed lap that the legacy automakers are still trying to finish. The benchmark for what a luxury SUV should be has changed. The only real question now is, how many more model cycles before the rest of the industry actually catches up?